Hi again, everybody. I thought I would work through one of these practice problems, see if this also helps you with your homework. This is homework problem 4 on page 311 of the supplement I gave you. Um, so we'll dive right in. Part A asks how many moles bromochlorine form when 2.74 moles of chlorine gas react with excess bromine. So this is just working with the molar ratio. So here we have 2.74 moles of Cl2, and we want to know how much bromochlorine we're going to make. And we're not worried about the bromine because it's in excess. So the molar ratio is for every 1 mole of chlorine gas, we get 2 moles bromochlorine. All right, so that gives us, what is that, 5.5, something like that, moles of bromochlorine. All right, so let's move along. You guys can do the math yourselves. 4b asks how many grams of bromochlorine form when 239.7 grams of chlorine react with excess bromine. So I hope it's clear by now. What you need to do is first go from grams of chlorine to moles of chlorine. And then what you'll have to do is then you'll get moles of bromochlorine, and then you'll have to take that and go from moles to gram using the molar mass. It's hard to draw without a pen here. Bear with me. A little bit ugly, but we'll get it. So we have 239.7 grams chlorine. All right, so what we need to know is what's the molar mass of chlorine. So from the periodic table, we have 35.5 grams per mole of chlorine, but it's a diatomic gas, so it would be 71 grams here. So 71 grams of chlorine is equal to, what goes here? 1 mole. All right. Then we can set up and we can use our molar ratio, and we know that for every 1 mole of Cl2, we get 2 moles bromochlorine. All right, and then we know, so we can do this all in one big step. So after the first bit here, we'll have moles of chlorine. after this step here, we'll have moles of bromochlorine. Then the final step is to use the molar mass of bromochlorine, and we say 1 mole bromochlorine. From our periodic table, bromine is 80, chlorine is 35.5, so that's 115.5. All right, so then you'll just have to work through the math and you can get there. All right, so that was 4b. So for the last one, what we need to do is we need to be able to go between number of molecules of gas, and to do that we just use Avogadros number. So 4c says how many grams of bromine are needed to react with 4.53 times 10 25th molecules chlorine gas. All right, little caret here being an exponent. Okay, so what we need to do first is, just like when we worked in mass, the first thing to do is to get to moles. So it's hard to draw with a trackpad here. All right. All right, so we have, the first thing we have this time is molecules. So we have 4.53 times 10 to the 25th molecules. So Avogadros number tells us that we have, come on, 6.02 times 10 to the 23rd molecules in 1 mole of chlorine. And really, we should say this here. All right, and then we know the molar relationship between chlorine and bromine. So for every 1 mole of chlorine gas, 1 mole of chlorine gas, we will react 1 mole of bromine. This is actually liquid. Okay, and then we want to know grams, so we have to say 1 mole bromine liquid weighs 160 grams. Okay, so are we on the right track? Our units are canceling. And of course I made a little mistake here. This should have been, yeah, I made a little mistake here. This should have been, control your surprise. Okay, so this should be, okay, now we're good. Okay, all right. That's why, that's a very good example of why we do this in this formal way, because it helps us catch mistakes like this. And you'll see as we go through, we now We've gotten rid of molecules, we've gotten rid of moles of chlorine, we've gotten rid of moles of bromine, and we now have grams of bromine. So just finish this through the math on yourself. All right, I hope that helped. Bye.